Let's look at some related rates trig problems from 2.6. So 38 says a balloon rises at a rate of 4 meters per second from a point on the ground, 50 meters from an observer. Find the rate of change of the angle of elevation of the balloon from the observer when the balloon is 50 meters above the ground. So let's list out some information that we do know. Balloon rises at a rate of 4 meters per second. This triangle represents the information that we're going to be using, with the vertical representing the vertical height representing the height of the balloon, so we can call that y. The horizontal distance between where the balloon started to rise with the observer is 50 meters, and then theta is the angle of elevation to the balloon for the observer. So we know dy dt is going to be 4 meters per second, since that's the rate at which the balloon is rising. We're trying to find d theta dt because we're trying to find the rate of change of the angle of elevation at the moment when y is 50. So we have some information about y at this moment in time. So we're going to create an equation that will relate the variables and the information that we see here. So we want to involve theta, 50, and y. We have to use a trig equation, simply because we are involving theta. And so we're going to, if we look at theta, y, and 50, the trig equation that will hit all three pieces of information is going to be tangent, right? Because tangent of theta is opposite over adjacent. Tangent, we don't want to use sine or cosine because we don't have information involving the hypotenuse. So one more thing, we want to keep this y as a variable. Even though we're told that the balloon is 50 meters above ground, this is just a moment in time, but the overall relationship is that theta is changing, y is changing, and 50 is staying constant. So we want to create an equation that will represent the fact that we want to represent variables, use variables where the values are changing over time. So we don't want to plug in 50. If we plug 50 in for y, that means this distance is not changing at all. It's going to remain 50, and we know that's not the case. So tangent of theta is equal to opposite over adjacent. So tangent of theta equals y over 50. So here's our equation that will that we can start off with moving towards finding the derivative. So from tangent, the derivative for tangent is secant squared theta, d theta dt. So we're involving theta's derivative, and so we have to attach d theta dt. Y over 50 is the same thing as 1/50th times y. The derivative for 1/50th times y is coefficient stays, y goes to 1, and we attach dy dt. Okay. So let's see what we can do here. We're not going to be able to know what theta is, but we can figure out what secant of theta is. We're trying to find d theta dt. We have a substitution in for dy dt. We just need to find a substitution in for secant of theta. So let's go back and look to see if this y equals 50 will help us find specific values around this triangle. So we know y is 50. We know the horizontal distance is 50. So we can say, using Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. And combine the constants values together, we get 5,000. 5,000 equals z squared. So z is equal to the square root of 5,000, which is 50 root 2. So at this moment in time, when y is 50, we know x is 50, and we know the hypotenuse is 50 root 2. So we can use this to help us substitute in secant of theta, because we know secant of theta is adjacent over hypotenuse. So hypotenuse over adjacent is the reciprocal of cosine. So 50 root 2 over 50 reduced to be root 2. So we can replace secant of theta with root 2. So root 2 squared replaces secant squared theta. dy dt gets replaced with 4. And then we can solve for dy dt. So root 2 squared is 2. Divide both sides by 2. The same thing as 1/2 times 1/50th times 4, which is 1/25th. radians per second. 39, same idea with trig. We're dealing with the right triangle as well. A fish is reeled in at a rate of 1 foot per second from a point that is 10 feet above water. At what rate is the angle theta between the line and the water changing when there's a total of 25 feet of line from the end of the rod to the water? So from this right triangle here, we know x is 25. That's the length of the wire or of the string that's being reeled in here. So 10 is the vertical distance and theta is the angle. So sine of theta. We want to be able to find the trig equation that's going to relate the three variables here. So sine of theta is equal to 10 over x. Sine of theta is opposite over hypotenuse. So that same thing as sine of theta is equals 10 times x to the negative 1. And if we find the derivative, sine becomes cosine of theta, d theta dt. Going through power rule, we get negative 10x to the negative 2 dx dt. We're told that there's a moment in time when x is 25. So the line is 25. D theta dt is what we're looking for, and dx dt is the rate at which the line is being pulled in, so negative 1 foot per second. So after we find the derivative, we can use this information to kind of make our substitutions. So we know x is going to be replaced with 25. We're looking for dx dt. I'm sorry, dx dt is negative 1, so we're trying to find d theta dt, but we need to figure out what cosine of theta is. So to find cosine of theta, we're going to go through the Pythagorean theorem to find the missing lengths here. So we know this is 10. I'm going to call this a. So a is the horizontal length, and 25 is the hypotenuse at this moment in time. So 10 squared plus a squared equals 25 squared. We solve for a, which is square root of 525, which is 5 root 21. So cosine of theta is just going to be adjacent over hypotenuse. So 5 root 21 over 25, which reduced to be root 21 over 5. So now we have a substitution for cosine of theta. So cosine of theta gets replaced with root 21 over 5. So now the only missing variable, we should be able to solve for d theta dt, because we can replace x with 25, replace dx dt with negative 1. And when we solve for d theta dt, we get 50 divided by 625 root 21. After we cancel out what we can cancel out, we get 2 over 25 root 21, which is 0.017 radians per second.